So we started with this semester summarizing the data set, right? We try to understand various kinds of data set that are available, because exactly when we go for the real time situation, we may not aware that exactly how the data is available with us. Depending on the data availability, we need to decide how to handle that particular data. Okay, in that thought process, we also need to understand sometime, suppose you may be having the data some 1 week or some huge data, let us say one year data. Now on a particular day you may not have the data, there is a missing value. Now the early days, what they were doing, they are processing without filling the missing value for the further processing. So when you do the prediction during that time, most of the time they were getting the false predictions, because you are removing the missing values and then you are moving forward. So that is why data exploitation takes place. To recover this or to fill those values, we have the statistical methods, statistical averaging methods. So those are whatever we are discussing now: mean, mode, and standard deviation. Mean, mode, median. This will help you to fill the data, but whereas standard deviation and variance will help you to understand how much variance is there within the data with respect to the particular parameter, or with respect to average. If you have, when you calculate some average, right, with respect to average, you will try to understand how the entire system is moving, whether it is moving in a perfect or not. So with respect to the average, we will be calculating even the rank that you are getting, right? The relative rank system also depending on the average that you are getting, class average. So overall class average depends on the your relative grades also. Sometimes what happens, the student who within the classroom, let us say the highest marks is 70 out of 100. Whoever got 70, right, he will be getting the top marks, and rest of them will be allotted accordingly, depends on the average. With respect to average, it will move left side and right side. So that's how even we discussed about normal distribution also, right? In the normal distribution also, it was the same thing we discussed. And anyway, we'll see with the slides now. So if you look at here, yes, the averaging methods are always, see, when you calculate, when we have a data, and then you try to calculate what is ultimately you'll be getting some numerical value. So that is called central value, we can say, or central tendency value. Also we can say average value. So that only indirectly mean, mode, and median. Anything we can say average. Okay, Nama. So these are the measures of central tendencies we have, right? You know the difference between all these three, right? What is mean? How you will calculate mean, ma? Mean calculation. How you will get mean? Anyone? Sum of observations by number of observations. So when you that depends on the data. Actually, if you have ungrouped data, then we can directly apply the formula and get the things done. But when we have a grouped data, then again you need to have, you will be calculating sometime mid value, and then you may have a frequency value. Both you will be multiplying and then you'll be calculating, right? So that way also we will be discussing, because calculating the data availability is here. Right now we have two ways. One is grouped data, ungrouped data. So you need to understand how to handle the grouped data, how to handle the ungrouped data. These two things are very, very important, right? So here, so to understand, like to calculate them only, we have here, you can check it out here, right? So here for the mean, we have given here, you can check, right? Check it out. The mean calculation is the sum of all observations by total number of observations. And similarly, mode. How you will get mode? Anyone idea? Anyone has idea? The number of times the particular value is repeated, right? Whichever the number is repeated more time, that number will be the mode, right? Here, if you observe the number, two numbers, where in mode. That's why you will be taking average then, because these are the some certain cases where it failed. So that is why we are discussing again with formula. So these are the shortcut methods, because mode and median have some falsifications. So that is why we are calculating by using the formula. I will be writing right in terms of grouped way. So that can be done, or you can take average mostly. Okay. So whichever the number is repeated more time, that will be the mode. Suppose if you are getting the more number of times, many number of numbers are there, then you can use other method or any other things, right? Even you can use the mean to calculate, because while dealing with a particular thing like mode, there will be a specific, like they may understand that, like if you have more number of, like let us say we have 100 times, the same number of times same number is repeated, then you'll be getting same, right? How you'll get two numbers repeated same? How you'll get two numbers repeated same? Getting my point? 7 is 7 only, right? Whichever the number is repeated many times, that only the average, right? Two numbers can't be repeated same time, right? How? Not possible, right? So that is why, because mode also will fail sometime, because see here 7 is there, next 3 is there. How it will map overall average 7? Some falsifications are there. That is why we are calculating the standard deviation and variance. So now, whenever you say some data, right? So you have to, don't make noise. Who came late? Just. So whenever you calculate variance or mode or median, so the reason is like we need to have, we also have to give some error also. Means let us say, I would like to say that this class average is 45 with a standard deviation of some value, means with error of some value. So when you give this way, so people also understand better way, because rather than giving only average, because whatever the average that you are prediction, that is not exact value, right? We are prediction, approximate value, right? So that is why while predicting the value, we can also say that whatever the value that you are saying, that with that error also, then it will be good. Like whatever you do AML, right? Machine learning algorithms or AI algorithms, what it does, AI algorithms will do only, it will give you the performance matrix, right? At the end, from the performance matrix only, you'll try to understand whether it is true or not. That's all. Means it will give you the average as well as error value. Both values it will give you. Then you will try to understand like, oh, this is the error and this much a percentage of error that is available in the system. So that way you try to understand and improve the accuracy. That's how the algorithms has been developed. Okay. So in the same way, median will be, so you have to arrange in ascending order or descending order. Then whichever the median value is there, that will be the median. Right here, if you observe here, so when you arrange ascending order, so here even numbers is there. So whenever you have an even number, take the middle topmost to average. This to average. Okay. Correct, Nama. Because while calculating the median, sometimes you may have even number of observations. So whenever we have an even number of observations, what you have to do? We have to calculate the average of those two numbers. Okay. Is it fine? Next. So this is general formula for the mean calculation. Sum of observations, right? Sum of observations by sum of observations by the total number of observations. So whatever you have, add all of them. Suppose you have, these are the data that you have, right? 2 plus 4 plus 6 plus 8 plus 10. So how many are there? 5. So the denominator will be getting 5. All the numbers will be added there. Okay. Next. So similarly, mean for the group data. How you will calculate for the mean group data? Because this was a mistake that we have done most of them in the class test. Remember here, ma. So for the mean calculation for the group data, what you are getting? Additionally, the frequency will add. So you have to calculate summation, the frequency value into the particular mid value or whatever the value you have, frequency value, right? So both you have to multiply and then you have to calculate. And here, what is sigma f here? Sigma f is sum of the observations, right? Means frequency values. Observations are here, frequency. So while dealing with the group of data, you have to be very careful. So when you are dealing with group of data, so we have formulas here. So here, if you see here, sigma fx by sigma fx, this we can also write capital N. So N is here frequency value. Listen here, last. So what is sigma f here? Capital N, that is sum of the total frequencies. And here, why we are adding here frequency into mid values, the observed values. Why we are doing here? Because here the data is in terms of group data. So we do not have direct X values, right? Observed values. So to get observed values, we are using this. Okay, done. Next, by using this formula, you can calculate now. Next, for the median, how you will calculate median? Median also the average value, but so for the calculation of median, one has to assess first. Initially, you have to arrange either ascending order or descending order. Any one order you have to arrange. Whatever the observed values you have, that observed values we have to arrange in a ascending or descending order. And then once you arrange them, then what is next task? You have to look for the mid value. Whichever the value is there, mid value, that is the mid value, right? Median, sorry. So median value. So you'll be taking that value as a median. So that if it is n by n is odd, then n plus 1 by 2 observation. N plus 1 by 2 observation actually, right? If you observe here, if you follow this directly, so suppose total number of observations you have 10 or 11, let us say 11 plus 1 by 2 is 6. So therefore sixth term will be the median for the particular given data. So that's what the meaning there. Okay. Similarly, suppose we have the even number of observations in the data. So whenever we have an even number of observations in the data, so what is how you calculate average now? So there we have to take two values. One is n by 2. Let us say we have 10 observations in the data, right? So how you will calculate now? 10 by 2 is 10 by 2, 5. So 10 by 2 is 5. Next, 10 by 2 plus 1, 6. So now 5 and 6. Whatever the observed values are there, in the position 5 and position 6, we will be taking the average of those values. So that's what the meaning here. Don't take directly the value. Okay? Correct, Nama? Observations there. This is the related observations. Is it clear? Any doubt in this? Calculation of median also done. Next. So these are some of the examples. You can see here. Initially, they were arranging in ascending order, and then so total observations are 10. Then, if it is even number, so we have to take two numbers average. If it is odd number, it is easy to identify the middle person, right? If it is even number only, it is very tough for us to identify the average. That is why we are taking the average of two numbers. So this is about the median calculation. Next, whenever we have a group of data, again calculation of median will change, right? So this is the formula that we follow, right? L plus n by 2 minus f by f into h. So here, listen here, while writing the examination, don't write directly. Write each term and define there, because the papers are going to be shuffled. We don't know who is going to evaluate your papers, right? So that is why clearly write all the data, given data first, and identify the terms each term. Okay. Next. So what is L here? L is here lower boundary of the median class. N is the total number of observations, and capital F is cumulative frequency before the median class. Suppose if you identify median class, the next slide, if you see, so let us say, if I say the median is where? Let us say if I assume the median is here. So this will be the capital F. That's what we are saying, right? This will be the capital F value before the median class frequency. Okay, cumulative frequency. Observe here, cumulative frequency before the median class. See the terminology, if you read properly, we can understand easily. Okay. Next, small f is frequency of the particular median class. Okay. H is the width of the class interval. So this is the data that we have. If you observe here, in a college assessment test, the marks obtained by 40 students are grouped into the following class intervals, because here they have mentioned clearly it is a group of data, because the data is given in terms of group, and now they were asking us to calculate the median. So now if you observe here, so 10 to 20 there are 5, and 20 to 30 there are 10. Similarly, they have given data, right? Rest of the marks, 40 student marks, right? If you observe here, this will come 40, I think, number of observations, right? If you calculate the cumulative frequency also, you'll get 40 only maximum, because they mentioned clearly there. So now from here, identify the median class. So we have 5. It is easy for like highest frequency wherever you have. So that will be the median class usually will take. Otherwise n by 2 median one. That also you can take. Okay. So now whenever you find this is highest frequency and corresponding lower boundary is L. So this is L. And you know how to calculate cumulative, right? Initially you'll be writing 5, 5 plus 10, 15, 15 plus 10, 12, 27. So that is the way you have to calculate cumulative frequencies. The cumulative frequencies has to be calculated the previous value and next value. Correct, Nama? Any doubt? Clear? As of now, clear? Huh? Next. So these are the same thing we are given the calculations, right? N value is 40 observations are there. So 40, and L is lower boundary, right? 30. Median class. L is 30. Capital F is, what is the terminology we have given? Cumulative frequency before the median class. So this is median class. Before this is, right? So that is by 15. Similarly, the corresponding frequency, that value, small f, right? This is f. And h value is length of the class interval. So 0 to 10, 10 to 20, 20 to 30. The length is, difference is 10. So that is why the h value is 10 there. I think this only, right? H value 10. Then substitute them, all of them in the formula, and things done. Okay? Any doubt in this calculation, ma? Any doubts? Fine. We'll move further. I think this is related to summarizing the data sets, and now we will try to understand lecture 3. Okay, ma. So as of now, we have discussed about the averaging method, right? So there are mean, median, and mode. And see, once you calculate the averaging for any system, there is another thing that you need to decide. Like with respect to the average, like whatever maybe, if you take the system, like let us say you have some company, you want to understand from the employee's perspective, the average salary is in a particular company is, let us say, some 1 lakh. Now you may be having different targets that I want to remove below above the average whoever is there, because what is their outcome? If you are paying more, whether they are doing really the amount that you are paying or not, that you need to check, right? To understand all these phenomena, one has to understand the standard deviation and variance. So once you calculate standard deviation and variance, then we can get to know with respect to average how much distant they are. Those things you can easily calculate from this. Okay. See, when you go for the real-time system, they will not say that go and apply the standard deviation, get things done. They will give you the task. This is my employees directory. I have this many employees. The average I want to remove the in a particular company, so whoever is there in the top, let us say, or whoever is not performing the well. So how you will identify these things? You should understand yourself. You should understand yourself. So if I want to understand who is the below or who is on the top, so you need to calculate the average. From the average, one can say, oh, these people are performing average, means up to the mark. Then above the average, whoever is there, they are the top performance in the particular company, right? And below the particular average, we can say they are like you can also have a categorization there. There may be a below average, closer to the average. We can say that okay, somehow better they can improve. And if you see the very long from the average, then you can say that they are not up to the mark. Then you can send them. So this is how you need to decide. See, the real-time projects will be different, but the handling the things in mathematically different. But you will be applying ultimately the mathematical concepts only there. Okay, clear? So this was the motivation that you need to study about standard deviation and variances. Clear, ma? See. So one can draw the drawback of range, the arithmetic mean of the k deviations from the mean. How you will calculate variance? Square deviations from the mean means xi minus x bar whole square you will be writing, right? That xi values are the mean deviations, means x1, x2, x3, x and so on. And x bar is the average. So that is mean, average value. From the mean average value, each deviation you will be subtracting, and then we are making the square of that. After that, we will be adding them. Right? That's how we will be calculating the variance. So that means there only it will say that x minus x bar. They are mentioning, right? Not that bar. Okay. X minus x bar. Xi means x1 bar, x1 minus x1 x bar, x2 minus x2 bar, x bar, x3 minus x bar, and so on, right? So that means average. From the average, you'll be understanding about each pattern, each observation, how much they are distance, right? How much distance they are. So that's how we are calculating, and then we are moving further. So the same thing we will be doing here. See my xi minus, you can see, observe, you can observe here the formula is so this is the formula xi minus the formula is so xi minus. So don't bother about now sample or population variance. You deal with only the variance, that's all. Whatever it is, follow any one symbol, either mu or x bar. Okay. So here xi minus x bar whole square by n minus 1, right? N minus 1. So now while calculating this, they are simplified version of this actually. So anything you can follow, but better to follow this only, because while calculating the deviations, if you take square values, square deviation, sometime you'll get huge value. Let us say we have an example. I have the values, x values are 75, 85 and 95, let us say. If you take square of this value, what will happen? It will be more. Instead of that, take average of this and subtract each deviation. Then you'll get lesser value. Let us say now if I get average x bar is some 80. Now x minus x bar when you calculate, what will happen? From each deviation you'll be subtracting this. So minus 5, some 15 or 10. So this will be, so squaring these values is easy, right? Rather than squaring these values. So that is why use this formula only better. Don't take the shortcut formula. Okay, Nama? Clear? This is formula. Apply this formula. By applying this formula, one can easily calculate the standard deviation and variance. We need group data. Yeah, this is the data that we have. Let us say, so they have given you the number of traffic chalanas issued in the last year by month in a city reported below. Means month wise, they have given us what they have given. Month wise, whatever the chalanas they are issuing, right? Traffic chalanas. Whoever missed the signal, they will be generating some signal report, right? Chalanas. So those chalanas they have given here. How many they have generated? So in the January 19, February 17, March 22, and so on. Till December, it has given. Now, we want to identify what is the standard deviation from each month in a year and what is the variance in the overall year, and so that you can plan for the next year. Even this will help you to understand the future prediction also. Future, what is the plan? So that way also one can do. So now here, whatever the value we have, right? This value is more. Take average of these values. Let us say this is x1, x2, x3, and so on till whatever x10, x12 actually, right? Till 12 we have. Now, if you take average of this, let us take this as x values. Then first calculate x bar. How you will get x bar? X bar is equal to this sigma x by n, right? So if you calculate, if you take average of this all these values, you may get some value, right? Calculate that, and next year calculate the x minus x bar value. X minus x bar. Then you can also calculate x minus x bar whole square, right? If you calculate this and add them, summation of x minus x bar whole square, so that you'll be getting this value. Once you get this, and number of observations, you know, right? How many are there? How many are there? Observation 12. So substitute in the formula. Whatever the formula you have, substitute in there. You can see here the same thing. So if you observe here, x minus x bar and x minus x bar whole square value, they have calculated, and then you are substituting over there. Remember here, there is a difference in the capital N, small n minus 1. Okay? So be careful what you are using. Fine? Right now use only in one formula. So this is how one can easily calculate the on average how many chalanas are generating. With respect to this, what is the variance? What is the standard deviation? So this is the way one can plan it. you can understand, right? Next, in the same way, you can also see similar type of problems. Calculating the standard deviation now. Take observations x and x minus x bar whole square. Suppose if you have a two deviations, like two values like in the model, calculate both and compare. Like sometime what I want to understand is, let us say we have a cricketers, right? Sachin and Ganguly. Now I want to understand how much variance with the Sachin and Ganguly. So you have to calculate Sachin as x, Ganguly as a y. Calculate all the values, average values, and compare them in terms of average and standard deviations. How they perform and what way, year wise. There are so many analysis you can do. See now, the things that you are learning right now in mathematically, whatever the programming language that you are learning, try to implement there so that you will understand better. So see, whatever the learning things are, just don't like just for the sake of the marks. Marks are a different story here, right? Only thing is, matter is, only thing when you go to the company, they will speak about only what you have done in the during your UG. They will not ask you marks. By having the thing, projecting the thing doesn't make you anymore now. You have to implement. As an engineer, you need to understand the problem, and according to the problem, you need to address, right? Don't think that wow, I have not studied this concept. Again, I'll go and study that way, right? So that is why you practice those things. Whatever you are learning, try to implement in some programming software so that you will be having better understanding. Okay? So this is how you have to improve day by day. It's not that only you will be there in one place, stay back at the same place till the final year, right? In a day, each day, try to understand each one some new thing. One new thing is enough for you. Try to understand what you learn in each day, some new thing. So total you have 365 days in a year, 4 years. How many new things you can learn? So this is how you have to improve yourself. Okay? So don't think that marks may be there for the entering into the system, but after entering into the system, only thing a real time situation how you are handling that only matters. Okay? Those things you need to practice now, so that it is easy for you when you go for the company. Right? Any other doubts, Mo? So this is how one can calculate the averaging and standard deviation. With respect to the average, how much distance whether the system is, whether it may be the standard deviation or variance, how they are varying. See, the words may be the different, but the concept is same. Because if you are looking at the only some employee system, we can say that how much variance in the salaries. Suppose if you have sometimes like the rainfall system, if you want to understand rainfall that are happening in the Hyderabad and compared to Chennai, how they are changing. So if you want to identify the changing, then you have to look at the data, take the standard deviation and variance, move up. Simple. Because handling with the real, see, this is the case study problems, right? You have a case study also this time. Do you remember? The case study is something that you need to take the real-time data and then address the same thing, whatever we are discussing now. Take the problem, model the problem, tackle the real-time scenario, and then give the problem solution. And at the end, we are going to give how they are varying. Like let us say, whatever the problem that you are addressing. If you are looking at a rainfall system, let us take the rainfall at different locations. See the situation, how they are changing. Okay? Is that clear? Any doubt, Ma, as of now?